Everyone, we're in New Orleans tonight, just back from the Gulf of Mexico, where BP is about to take a big step in trying to get control of the oil leak. It will test the new containment cap it installed on the wellhead to see if it can handle the pressure of the oil pushing into it. That test had been delayed today out of what the government called an abundance of caution. The concern was that putting more pressure on the already damaged wellbore could do more harm than good and could even create more leaks. But late today, BP got the go-ahead for the test to begin. Meanwhile, the siphoning operation continues above the well, and we went out there today for a first-hand look. I headed out to the disaster site with the government's point man, Admiral Thad Allen, and Interior Secretary Ken Salazar. We landed on the Helix Producer. Unlike a rig, it's not moored to anything on the ocean floor. It's a ship, and a GPS keeps it in place. It's a dramatic sight. Oil is pumped in through a riser. Then after it is separated, the natural gas is burned off. Ever since the HP-1, which is called a floating production unit, arrived here on June 19th, it's been ramping up its capacity to collect oil. Its target is to be able to collect some 30,000 barrels or 1.26 million gallons of oil every single day, and then pipe it into that tanker right nearby. The Helix Producer will get an assist from 3 other vessels. Ultimately, 4 vessels will be charged with really siphoning up the total amount of gas or oil that's coming up.
And we believe that'll give us 60 to 80,000 barrels a day, which is above our current flow rate estimate.
So that will at least stop it, right?
It will contain all the oil.
But then obviously the relief wells will actually stop it for good.
Stop it for good, exactly right.
This is really Plan B. Ideally, the latest device, the so-called capping stack, a massive piece of equipment weighing 75 tons, will stop the flow completely. But testing was delayed because scientists were worried about putting too much pressure on the drill pipe and well bore below the seafloor.
We've now seated the capping stack.
But after a day of intense review and debate, the test was green-lighted late this afternoon.
And at this time, we'll be releasing an order to BP to proceed with the well integrity test.
Engineers will first close off the valves on the capping stack, which should trap the leak inside. With all 3 valves closed, they can measure the well's pressure. A high-pressure reading of 8,000 pounds per square inch means the well is in good shape, but a low reading means oil is still coming out somewhere below.
If we get to a point where we're around 4,000 or 5,000 psi and it does not rise, that's like a garden hose where not as much water is coming off, so where is it going? And that might be an indication that the oil is going someplace else. So we won't know until we actually close the system and start bringing the pressure up what that will tell us. It's 8,000 on the Q4000.
Meanwhile, a symbol of both man's engineering ingenuity and corporate hubris, this industrial city on the water is a massive show of force, waiting for its next mission.
I don't think there's ever been an aggregation of drilling vessels, production vessels, and vessels supporting remotely operated vehicles, probably, at least in the history of the Western Hemisphere, maybe the world. And I think we're really going to have to think about the systems that support offshore production and how we're going to respond to one of these in the future.
Capping the well and containing the spill are a temporary fix. The permanent solution will be when those relief wells are completed in mid-August and the leak can be plugged with drilling mud and concrete.